Hello guys, welcome to TuxRiders. From this video we want to start a new series in which we want to discuss the concepts of FreeFEM, the finite element language that we use a lot in TuxRiders. So let's go for it. So FreeFEM, we already used FreeFEM in a couple of videos in TuxRiders in the finite element series that we solved a single problem with different tools. The first tool was FreeFEM. You can find the link in the description, and also we covered the installation process, or let's say the build process of FreeFEM in one of the videos in Set Up Your Environment series. And as a result, I don't want to discuss the installation. Installation is so easy to do. You can download the binaries for different operating systems and also some Docker images. The latest version at this moment is 4.11. But yeah, as I said, I don't want to discuss the installation. So installation is quite straightforward. But from this video, as I said, we want to start to talk about FreeFEM. We cover different aspects of it. The first video is dedicated to its syntax and language concepts. But it's worth mentioning in the beginning that there is a very nice documentation for FreeFEM that covers almost any aspect of it. So it's here, as you saw, click it in the documentation, and then this documentation, for different, subdomain of FreeFEM language. You can find the relevant things here for mesh generation, for finite element, let's say spaces and declaration, and also solving equations for parallelization, and also for BEM, a little bit visualization, all these things. But what I want to do in this series is a bit different from the approach that the documentation has taken. And that's actually, discussing each subdomain, each field, each part that we want to discuss using a set of examples. And these examples are coming from, some of the projects that I did in FreeFEM, and also partially from the examples that the developers have provided. So let's just start with the examples. I will open, open the folder with the Tom so that we can see all the examples. And then in order to run this, for FreeFEM, this is something we already discussed, that we can call FreeFEM++. And if I run it without any input, it prints the citation information and also the arguments and a version. So you can see that I'm using 4.10. So my install version is not up to date, but it is still quite recent. So in order to run these examples, we will cover those examples first. And then, for example, for running the first one, it's enough to write FreeFEM and then name of the example. In Windows operating system, when you install FreeFEM, it's also, you don't need to do this. You can also, you can double click on the result files, on the codes, and then it's easy to run. The FreeFEM interpreter or runtime language will automatically run the program and display the results for you. But in Linux, in command line interface way, it is this is the way that we run the codes. So for example, in this case, you can see that I run it, and then I have the output of the program here. It says that this is a normal end. But it also prints the source code. This is also quite common in FreeFEM, and sometimes some warnings. The first thing to cover, probably the first thing to talk about, is that you can easily suppress this output, especially for the source code, with setting the verbosity of the code of the program to 0. So this is quite interesting, quite important, and quite useful in some cases, that you turn off the verbosity, meaning that, like asking the program not to talk a lot. So some of the error messages, some of the warning mostly, are also suppressed. But an important effect is that it doesn't write the source code of the program into terminal. So this is quite useful. Okay, so let's start with the first example that prints something like this. This is, the syntax of FreeFEM, which is very similar to C++, almost the same, resembles C++, and there are some minor differences, especially for the variable types and the way that it treats variables, and also some implicit conversion, these kind of things. But if you know C++, this is there is no need to learn the language. And if you don't, I can tell you that it is simpler than C++. In C++, there are a lot of concepts that you need to learn, but FreeFEM is not that much complex. So the first example is related to basic math and basic variables. So you can see that we can have different variable types. Real is the floating point numbers. So it says that, yeah, two values here, two variables, x and y. X has a value, an integer. And a complex is also something very useful, and later on you will see that we have also strings. So in order to write the value of x, for example, here to the terminal, is really like C++, as you can see, and redirection operators, but we don't need to include anything like IOStream or something like that. And as you can see here, when we say x equals like 3.14, it's actually the output of this. So these examples are quite easy to follow. I don't want to discuss all the lines here, but I will point out only the headlines, let's say. So here you can see that these are the way that you can use basic arithmetic. As I said, these are very similar to C++, and then you can also write, go to the new line instead of end all. You can use /n as a new line, and then for complex numbers, the way that you can define them, you can use them is using this predefined or built-in, for the imaginary part, I. So 10 minus 10i is actually kind of complex numbers that are printed on the terminal like as easy as this. So and then for controlling the way that a cout works, so this is also quite common in C and C++ programs, that you define the precision, the level of precision you want, and also the notation. Sometimes it's scientific notation, sometimes you want to have it like fixed point notations and this kind of stuff. These are also possible in FreeFEM. This can be quite handy in some projects. We will also use them later on in other real projects that I want to show you. And this is a way that you can write a real part of a complex number and the conjugate part. And then we have the unary operators, plus, and the way that the different ways that are written here. So the same concepts in similar to C++. So in this notation, it is first increased and then printed to the terminal. But in this case, it is first printed to the terminal and then increased after this statement. And then, as I said, we have strings. Strings are also very useful, like any other programming language. So strings, and then it's very similar, double quotations. We don't have any single notation, single quotation, and then the way that you can write it is like this, and to the terminal as well. And then for the if and for loop operations, we have the same syntax. So as you can see, the same concepts as C++, that you define first the iteration variable, and then the limits, and then the increment, or the way that these variables should reach here. And then here you can see that we have also trinary operators, that it is like if x equals 0, then this one, and else this one. This is really like question mark and colon. So this is actually the output of this program, the first example. And then the next example is related to array and matrix operations that are quite useful in finite element world, that are very handy. There are two examples here. One is actually a trimmed version that I have for the very essential concepts, and then there is another one that is full. You can see that it's very long. You can check it out later. There are a lot of concepts that are discussed there. But in this case, this is a trimmed version, as I said, that I only extracted the required concepts here to discuss in this video. So the way that you can define arrays is a little bit different from C++. You can see that here it says that we have a real, let's say, array with a length of 10, but it says that the index is integer. So this notation means that the values that we store inside the array are real values or floating points, but the index is integer. So this is quite trivial in C++ that the index is integer, but in FreeFEM the index can be something else, from another type. Like in this case, it can be string, acting like a dictionary in other program languages. It's the same map. This is actually the key equals 2. That can be something else also. It can be a word or something from alphabets, from letters. And in this case, when it says 2, 2 is automatically cast to a string. So that's why this is actually written like this in FreeFEM. So then for array initialization, you can see that when you say that an array equals 1, it sets all the array elements to 1, and then you can also have the control on each individual elements. They start from 0. This is important to remember. And then we have n as a property of the array showing the size of the array. So let me run this example. So it is example 2 array.adp. So this is the way that the output is written, and I forgot to put v0 to suppress the verbosity. And as you can see that it's actually, when you see out the first elements, it was actually 2, and then the rest, and then the size equals 10. And then array operations is as simple as, like integer and floating point operations that you can add, multiply, and do whatever you want using arrays. So it works as expected. And as you can see, also for complex arrays, that is actually complex with index of int, the same thing applies also here. So that's actually the same. For this one, I said that it acts like a dictionary, like an array with the string index. And then there is another way to initialize the arrays. Instead of specifying the size, you can say it's something like this, array initialization, that is very similar to C++. And then here we have also resize, that is resembling something like MATLAB operations, that you can resize the arrays. This is something very difficult to get in C++, that you can resize something and then start to feel like the resize part. As you can see now, it has only 5 elements or 4 elements, and then we resize it to 10, and from 4 to 10, we can start to initialize it. And when we say print it to the terminal and divide it by 2 and multiply it by 2, then you can see that these are actually the results that we will have. So this is actually that part that is corresponding to it. Okay, so and then also for matrix operations or multi-dimensional arrays, it's also possible. There is another example here that we'll discuss it, but in this case it means that we have like a 2-dimensional array with 10 for each dimension, int, and then we can have like with n and m, these are the dimensions, these are the size of the array, and then we can iterate through it and set each individual component to the value that we want. And then we can also see it, print it, and the way that it prints it is like this. So that's actually the second example, and then we go for the third example, which is another notation for iterating through the values, through the elements of an array, that can be very useful in some cases in FreeFEM. You will see a lot of examples on this, especially for parallelization of simulations. That examples written in FreeFEM are written in this syntax. That let's say we have 2-dimensional array A in dimension 2 and 3, and then we iterate through it. It's like a for each statement in different programming languages. That you say for A, inside A, this is ij and aij. So ij are the index that goes through, and then aij is their corresponding index at each I and j. So you can say aij equals something relevant to I and j. And then if I run this, you will see what I mean. That is quite handy to know. That, for example, in this case, you can see that it iterates through 0 for I, 0, 1, and then 0, 1, and 2 for j, and then it starts to evaluate and assign each value that we want to each elements of A. And if we want to print A, then we can see what has happened to A. And then the same thing, you can see that for 1-dimensional arrays, it's also the same, but here we have only I and bi. that are going to iterate through B. And then the same thing can go for the matrix. Matrix is also one of the essential types in FreeFEM that is especially very useful, that is used a lot for finite element computation. We want to solve the AX equals B as a result of the linear system. And then here is the way that is defined. You can see that similar to two-dimensional array, this is something that we can define here. And when we print it, this is a special case for FreeFEM. It writes matrices like this. So this is it's a hash matrix and then a size, and then these are the things that are written. So this is a size, and then the elements are written like this. When you ask FreeFEM to print the matrix, it prints it to a special format. And then the next example is related to functions. So functions are quite useful when we want to, let's say, clean the code and make it modular. That you will see, we will do it later for the codes that we will develop. This is very important to make it clean, to keep it clean actually, because later on it limits the extensibility of the code and readability for other people that want to contribute to that. But the way that functions are defined in FreeFEM is more or less similar to C, I would say, but it's a combination of C, MATLAB, and Python probably. So we say func is the keyword that we want to use, and then the output and the name of the function and the input variables. So this, you can see that we have phi and then my function. So I'm accepting two input variables and performing something on that, and then it calls phi, and it should be defined first. If FreeFEM want to see it, it's very similar to C and C++. And then you can call them, and this is the way that it works. So I would say for, and you see that, yeah, it computes the value that we want to have. So this is something that you can see actually the difference. If I turn off the verbosity, you can see that it prints only the cout statement that we have in the code in comparison to the output that is really verbose. And then the next example is advanced functions. That is like, there are different functions that they can have. These are not different functions, but more advanced use cases of functions. Like, for example, when we have an array as the output, like we define an array inside, and then we say that, yeah, do something with the array, and then return A as a second element. So this is actually, this is prone to some errors, vulnerable code, because it should be n should be more than 2 because we assign the second value to something. But yeah, this is a kind of function that returns arrays. And this is another case that is common in C++. You see a lot. This is just to provide you with an example that this is also possible in FreeFEM, that you send something as a reference, and arrays are always sent with pointers like values. I don't want to go to the details of this. So you can have control on A. As you can see, the function can change it. So we send something to the function, and the function has control on that. So it is possible to to assign something to this. So this is BBB is something that accepts an array, changes it, and then returns the output as an array again. So this is the way that it is used. You can see that we have like A defined here, and double A, and then double B and triple B is performed on that. And when we print it, you can see that it tries here as assert, meaning that check this, and if it is not true, exit the program, meaning that there is a problem here. So this is the way that you can see that it checks if the first element is 100, and that's because we have control. Otherwise, this was not 100 in the initialization, but after we pass it to the array without reading the return of the function, output of the function, it is changed inside this function. And there are also there are different other functions that are useful. Is infinity, is not a number, and is normal. These are the things that are useful. Let me run this example. and you will see that x5. So here you see that it says infinity. So this number is actually very big. So FreeFEM reads this as infinity, but it is not a number. It is a 0. And then it says 1. It is not infinity. And then is not a number, it is a number, so it is okay. And then when we say xNaN, not a number, and then you can see that it returns something like this, and then it's not infinity, it's NaN, and it is also not normal. That's why it is 0 here. And then the example 6 is related to macros. Macro is a concept that is similar to the concept of macros or inline functions in C++, but it is very, very useful in FreeFEM. You see a lot of examples with macros, especially for finite element computation, for computing the divergence, gradients, and those kind of things that you require in diffusion-based systems or convection-based systems. So this is why I included this, because this is important to know when you want to check those examples and we want to study them. So what macro does is actually a kind of concatenation, and then and it means that when we have like test u, it says that just print u, put u as the output of this. And then when you say, for example, here test2u, return u hashtag or number sign xx, it means that whatever it comes to this, then we will have xx concatenated to it, added to it, and then we return it. So you see that we have strxx here defined and not str, but when we send it to test2, because it concatenates xx to it, then it will be printed as check. Let me run this example and you will see that it doesn't complain about it. Otherwise it seems that it should, but it doesn't. As you can see that it prints check, although we have passed str to that, which doesn't exist. So in this case, when we have something like divergence, something like this, that it is this partial derivative of the function, like the summation of that, when we pass v to that, it can be any variable, it returns something like this. And that's why this notation is very, very handy in finite element computation. Then for the exceptions, this is also very useful in most of the programming languages, that you want to catch some of the errors that occur in the code. For example, in this case, we have division by 0, and then we have some workaround for that. We expected it here. So instead of something, an error that terminated program, here we catch it and then we do something with it. We say if it is division by 0, then a equals 0. So you can see here, let me run it. And you see that for this one, it has the error. It says that the execution error division by 0, but the program doesn't terminate. You can see that it says that it's a normal end because of this catch statement, let's say. Because it says that if something problematic happen inside this try block, this will catch it. And this is very useful. You will see in the future that we use this for like file handling when you want to look for a file, because FreeFEM doesn't support like sophisticated file operations that want to check if something exists or not. You can try, for example, to open it, and then you will have try catch, and in case of an error, you know that the file doesn't exist, and then you can go for alternative solution that you have in mind, or you can go for the program logic. So this is why I put this example here as the example 7 and exceptions. Example 8 is related to sizing. As I said in the array example, this can be useful in some cases, especially when you want to read something from a file. So you see that you define something and you resize A according to the size of B, and then you can have the operation on it. Another reason that I put this example here is the difference between multi-dimension arrays and an array of array. In this case, V is 10 elements that each element has its own array inside. So this is fundamentally very different from this one. In this case, it's an array like a matrix. But for V, as you can see, we iterate through the first dimension first. It is only n. For sure, there is no M here. And then each element is an array. And it means that we can resize it to something like this. So each array is resized to its index elements, to the index value plus 1. So it will be like a cascading thing inside FreeFEM. And in this case, you can see that, again, we iterate through the elements of the internal array. In this case, you can see VIN, there is no M here, and we assign values, some values to that. But in this case, this is a kind of matrix that we already discussed, and we have N and M, we can iterate through it like this. And then you can see that here we will have like MATLAB-like operations on slicing and indexing of matrices and two-dimensional arrays, which can be very, very useful, especially for post-processing and for analyzing the output of simulations and stuff. So as you can see, slicing are supported, and also partial indexing and all these things. These are all supported in FreeFEM, and as you can see, you can also have sum of a column. So it says all rows, and then the first column, in this case, this is the second column because it starts with the 0. And then the last example to discuss is related to command line interface or command line arguments, that we need to include something here. As you can see, we include, so later on you will see that we have load for different modules. We load something or we include something. In this case, it's an external code. So the normal files for FreeFEM are EDP, and in this case it is IDP. So a getarg V is actually an external code that's provided by FreeFEM developers that you can use to read the arguments from the command line. So in this case, we haven't discussed mesh generation and stuff here yet, but this command produces a mesh. This is just for checking. So it says that if I write something, pass something called size to the program, then it is assigned to N. And if I don't, then it will be like 5 by default. So when I run this example, let me run it. It's example 9, and verbosity should be turned on. I don't want to have a lot of things here. So when I say 0, then size is 5, and as a result, the mesh that I will have has only 5 elements in each edge. But if I pass size to that like this is an argument that I pass on the command line, like 20, and I press enter, you will see that I have 20 elements in each edge. So this is very, very useful, especially when you want to run FreeFEM programs externally, like as an external program executable that is useful for optimization cases, or you want to have some automation that controls FreeFEM using a front end or something. This is very useful to communicate with the FreeFEM code from the command line. You will see examples later in the projects that we will discuss. And in this case, there is another example that it says for strings that it is like config we have with a C. This is the name, and then the default is default. So it says, it prints the configuration is config. So if I do not provide it with anything, you can see that it says the configuration is default. And if I do something like I say C is like, I don't know, optim, you see that it opens this one. I can also suppress the graphical output, but it doesn't matter. And it says the config is optim. So yeah. These are the things that I wanted to discuss for the basic language concepts. As you saw, language is quite simple, it's quite straightforward to work with, but it is also sometimes because of some differences with C++, C and C++, it can be like you need a reference to refer to. And as I said, the documentation is available on their website, but I also tried to have like the most essential concepts covered in this example. I hope you enjoyed this video. Stay safe and see you later. Bye.